Hi everyone, this is V. Naidu, MSc Physics. Today our topic is conservative nature of central force. Conservative nature of central force is one of the best characteristics, one of the best feature of central force. What is the definition? The central force is conservative because the work done by the force in moving particle from a point A to point B is independent of path followed. Are you understand this definition? No. Let us see this diagram. Let us take point A here and point B here. Now a particle is taken at point A. Now we apply a force. Then our particle goes from A to B. Along path 1, our particle goes from A to B along path 1, A, P, P dash, B, or along path 2, A, Q, Q dash, B. We know, let us take this is a particle. Now we applied a force on this particle. It will be small displacement will be occur. A force will be applied. It will be displaced. dr displacement will be occur here. Then what happens here? Some work will be done here. Let us take a particle here. Now we applied a force on this particle. It will be displaced. How much it will be? Let us say dr displacement will be occur here. Then what happens here? Some work will be done here. That small work done dw equal to f bar dot dr bar. You know. Now integrating both sides. Then what we get? Total work done w equal to integral f bar dot dr bar. What is our A? At point A particle is there. Now we applied an external force here. Then our particle moves from A to B along path 1 or along path 2. What is our lower limit? A. And what is our upper limit? B. Then the resultant work W equal to integral A to B f bar dot dr bar. Now we go from along path 1 A, P, P dash, B. A, P, P dash, B. Let us say that work done W1 is equal to integral A to B F1 bar dot dr1 bar. Now particle goes from A to B along path 2. Then some work will be done here. That work done, let us say integral A to B f2 bar dot dr2 bar. If w1 equal to w2, that means integral A to B f1 bar dot dr1 bar equal to f2 bar dot dr bar. That means our central force is conservative. Then only our central force is conservative. A నుంచి Bకి మనం మూవ్ అవడానికి రెండు పాత్లు అనేవి ఇక్కడ తీసుకున్నాం. ఒక పాత ఏంటి సార్ అంటే ఏ పి పి డాష్ బి అండ్ ఇంకొక పాత ఏంటి సార్ అంటే ఏ క్యూ క్యూ డాష్ బి. ఏ పాత గుండా మనం ట్రావెల్ అయినా కూడా ఫైనల్గా వర్క్ అనేది ఏంటి సార్ ఈక్వల్ అయితే అప్పుడు అక్కడ అప్లై చేసిన ఫోర్సెస్ అనేవి ఈక్వల్. ఇప్పుడు ఫోర్సెస్ are equal, that means central force is conservative. This is explanation about central force is conservative. Now let us see proof. You know this diagram already I will explain. Now we draw a arc with radius r. How much? R radius తో ఇప్పుడు మనం ఇక్కడ ఏంటో ఒక ఆర్క్ని మనం డ్రా చేస్తాం. దట్ ఆర్క్ ఇంటర్సెక్ట్ పాత్ 1 at point B, point P, path 2 at point Q. Okay. Now we draw another arc we draw another arc of radius r plus dr. We draw another arc r plus dr. That arc intersect path 1 at p dash and path 2 at q dash. Okay. Now let us suppose our particle is at point p or at point q. Now we applied a central force on this particle. Let us say F1 bar. How much force applying here? F1 central force. So central force and ela annaru. This is our fixed point. This is our particle. Force acting on this particle away from the fixed point. That's why definitely it is central force. This now we applied a central force on this particle P, then it will be displaced from P to P dash. Let us say that displacement, let us say dr1. That dr1 makes an angle F1 with, let us say, theta 1. Okay. Now central force act on the particle Q. ఇప్పుడు ఏంటమ్మా సెంట్రల్ ఫోర్స్ అనేది క్యూ వద్ద ఉన్న పార్టికల్ పై యాక్ట్ అవుతుందని నేను అనుకుంటాను. లెట్ us say F2 bar. Let us say F2 bar. Okay. Now our particle displaced from Q to Q dash, how much distance? Let us say dr2. The dr2 makes an angle theta 2 with F2 bar. Theta 2 with F2 bar. Clear? From the diagram, from the definition of central force, what we conclude? F1 bar is equal to F2 bar. ఇక్కడ ఫస్ట్ పాయింట్ మనం ఏంటమ్మా చెప్పగలం? F1 bar is equal to F2 bar. Because what is definition of central force? Central force is a force which is acted on a particle towards or away from the fixed point. This is also central force, this is also central force. These two forces acting on the particle at a distance r from the fixed point. That's why these forces are central forces. The central force depends upon function of r, distance of r. These two forces acting at a same distance, and that's why these two forces are equal. That means F1 bar is equal to F2 bar. And another one is, let us take x axis and y axis. This is our center. Now let us say distance x, here let us say distance y. Now we take it as a particle here, and let us take a vector r bar, radius vector. We take it as radius vector r bar. What is the projection of r bar on x axis? Anyone? What is the projection of r bar on x axis? Projection. Now we draw a parallel line to y axis. This is 90 degrees. Let us suppose our r bar makes an angle theta with x axis. Then cos theta equal to, what we get here? Cos theta equal to Hg sent by hypotenuse. What is our hypotenuse value? R. Then x equal to r cos theta. Now sin theta equal to what we get? Let us, this is y, so this is also y, both are parallel. Then what we get? Y by r, then y equal to r sin theta. Now what is the projection of r on x axis? What is the projection of r on x axis? How much we get? R cos theta, like that. See this diagram. What is the projection of dr1? What is the projection of dr1 on f1? What is the projection of dr1 on f1? Here this is dr1. Okay, this is F1. What is the here angle? Theta 1. Then what is the projection of dr1 on F1? What we get here? Projection of dr1 on F1. What we get? dr1 cos theta 1. Now, what is this projection? dr1 cos theta 1. What is the projection of dr2 on F2? What we get here? dr2 cos theta 2. Let us say this is dr2. Let us say this is F2. Then the projection of dr2 on F2. What we get here? dr2 cos theta 2. Okay. These two are equal. Sir, how is it possible? Let us see this diagram. What is this value? dr1 cos theta 1. This is equal to dr bar. What is this value? dr2 cos theta 2. This is equal to dr. That's why from the diagram dr1 cos theta 1 is equal to dr2 cos theta 2. See these two values. Here these two forces are equal. Here dr1 cos theta 1 equal to dr2 cos theta 2. From these two equations, finally I have written as F1 bar dot dr1 bar equal to F2 bar dot dr2 bar equal to, let us say, F bar dot dr bar. F1 dr1 cos theta 1 equal to, in this sir, F1 F2 equal, dr1 cos theta 1 dr2 cos theta 2 equal, means F1 dr1 cos theta 1 is equal to F2 dr2 cos theta 2. This is equal to, let us say, F bar dot dr bar. Okay. Now work done from A to B. Work done from A to B. What is formula? Integral A to B F1 bar dot dr1 bar. Antena kadamma. Endiki sir work done from A to B along path 1. Now we applied a force. Then we applied F1 force. It will be displaced. How much distance it will be displaced? dr1 distance. Then the work done along path 1 A to B equal to integral A to B F1 bar dot dr1 bar. It is equal to integral A to B F bar dot dr bar. F1 bar dr1 and then equal to F bar dot dr bar. Now work done from B to A along path 2. See this one. Work done from B to A equal to F2 bar dot dr2 bar. Sir, how it will become? Now we applied central force F2. It will be displaced dr2. Then that work done is equal to F2 bar dot dr2 bar. This is equal to again integral B to A F bar dot dr bar. చూడండి మరి దీన్ని ఎలా రాస్తాను? మైనస్ ఇంటిగ్రల్ B to A is equal to A to B F bar dot dr bar. జస్ట్ మైనస్తో మనం మల్టిప్లై చేస్తే లోవర్ లిమిట్ అప్పర్ లిమిట్ ఏమైపోతుంది నాన్న? లోవర్ లిమిట్ కింద కన్వర్ట్ అయిపోతుంది. ఇప్పుడు ఈ రెండు ఈక్వేషన్స్ మీరు చెక్ చేసినట్లయితే హియర్ LHS ఇంటిగ్రల్ A to B, సారీ, హియర్ LHS వర్క్ డన్ ఫ్రమ్ A to B, హియర్ LHS వర్క్ డన్ ఫ్రమ్ B to A, హియర్ RHS integral A to B F bar dot dr bar. Here RHS integral A to B F bar dot dr bar. If LHS are equal, then RHS also equal. Therefore work done from A to B is equal to minus of work done from B to A. Now work done from A to B plus work done from B to A equal to 0. Work done from A to B, then B to A equal to 0. That means the work done is independent of path followed by the system. Therefore central forces are conservative. Clear? Thank you.